All right, so today we're going to be talking about Chapter 10, Lesson 3. This is all about misleading graphs. So, when we are going through and looking at graphing data, we can actually use graphs to let us be able to analyze the data a lot easier. But we can also make them a little bit more misleading, and we can influence conclusions by misrepresenting data. So we can influence conclusions by creating a graph that misrepresents the data. For example, we can make something that is bad look less bad, or something that is good make it look better. The reason why we would want to do this is simply because if something is bad happening, we don't want other people to think it's as bad as it is, so we can misrepresent the data to make it look like it's only a small amount of decrease or bad. We could also do it with something that is good. So if it's a small amount of good, we can make our data look misleading by making it appear like it's a larger amount of an increase than it actually is. Businesses do this all the time. They do this because they want their stockholders and the people that are invested in them to think that they are doing well, or to think that their decrease is only a small amount. So let's look at example 1 here. It says the line graphs below, both A and B, show the sales for a local bakery. In fact, each graph shows exactly the same thing. So which graph makes it appear that the sales decline is only a small amount? And then, of course, would you conclude that it's only a small amount? And then, of course, we would want to explain. So, first of all, this graph here has a very gradual decline, where this one makes it look significantly worse. A big drop here, a big drop here, and overall, a pretty decent decline. Where this one, even the big drop, looks relatively small. We can still see that from the beginning to the end, we've decreased, but it doesn't look as bad. So A is the graph that shows a smaller decline. And could we say that this is a valid conclusion? Probably not. The larger the distance is between each one of these lines, so for example, this one is 600 and then 800, so each one of these intervals is 200 away from each other. The larger an interval is from each other, even if there is a change, it would look more gradual. Where in B, each line is worth 75, which means that we'd be able to see a lot more of a difference as we decrease. So having a smaller interval shows off a little bit more of the actual change that's going on, while this one here has a very large interval, so even if there is a decent amount of change, it wouldn't look very big. This change from here to here, which happens to be the exact same change from here to here, this one is about 75. It goes from 950 down to 875. This one, even though it's 75, still doesn't look like that big of a decrease, because it would be less than half of the distance between these two lines. So what we would say here is that this is not a valid conclusion because larger intervals. We could also say that these two graphs are going to be looking different because the intervals are different, which of course makes graph A look like it's a very small decline versus the second graph makes it look like a very large decline. So if I were a business, I would want to show off this one versus this one. The reason why is because I would say, see, look, the decline isn't as bad as everyone says. It's a very small decline. Yes, we're going down, but it's not that bad. Where this one, I couldn't say that because it looks like a huge drop from here down to here. So this one, I would want to not show anybody. Now, of course, if there was an increase, I would want this interval to be as small as possible so I can show how much growth we're having. So I would want to hide this one away because if it was showing an increase, the increase would be very small as opposed to this one. We always want to showcase the positives and hide the negatives. Now, we could also do that with statistics. So we could use statistics to show some things, again, that are positive and improve them, or we could show things that are negative and try to hide them still. So, misleading statistics. We always want to be talking about mean, median, mode, range, those types of statistical and pieces. Now, the thing is, though, in example 2, it says Michael and Melissa both claim to be earning a C average. Now, average, this would be looking at the mean. One student is wrong, however. First of all, which one, and how are they using a misleading statistic? Now, looking at these two pieces of data here, Michael is the one on the left, Melissa is the one on the right. As we go down, it looks pretty similar. And then it looks like Michael kind of fell off a little bit. Stopped studying maybe, or stopped understanding the material. Where Melissa, still kind of falling off a little bit. So it looks like these assessments definitely got more difficult. But it looks like Melissa did better on those past three than Michael did. Now, because we're looking at average, we would want to be looking at the mean of these numbers. So the mean of Michael's scores are 53.4. This is a failing grade. The mean of Melissa's scores is a 71.9. This is a C. So how can Michael claim to be having a C in this class? It's because he used the median. Median is the middle number, and these numbers already for Michael are written from least to greatest, so the median would be that score there, which is a 70%. Now for Melissa, these scores are not written in order from least to greatest, but if we simply rearrange these bottom three, none of them would come up into this top four, so her median is also 70. Which means, if we look at these two numbers, the closer these two numbers are together, the better the data set really is. Michael's numbers are very different, which means that if he has a median of 70 and a mean of 53, he did really well, and then started to do really poorly. So looking at these two numbers, Michael is the one that is not getting a C average. Michael is the one that is wrong because he used the median instead of the average or mean. He still used a statistical value that represents a center. He still did what was correct. The problem was he said he was averaging when he did not say his average. So he still has a median of a 70%, which would be a C. However, his actual average is a 53.4%. So he is using a correct piece of information, but explaining it incorrectly. So Michael is misleading people. All right, that's going to be the end of lesson 3. If you have any questions, please let me know.